Welcome back. We are now looking at the second page here, the midterm review, starting with problem 6, which is an exponent problem. A couple options here. I think the route I'm going to go first, I'm going to distribute this guy through and see what happens there. So I have 2 x to the 1/2 and x to the negative 1/2. Well, the bases are the same, and since I'm multiplying like bases, I'm going to add my exponents. A half and a negative a half make a 0. Minus x to the, and here negative a half and negative a half make a negative 1, all over x to the negative 1. Well, remember the definition of x to the 0 is 1, so I have 2 over x to the negative 1 minus x to the negative 1 over x to the negative 1. So I simply split my fraction up. I unsimplified it, if you will. So we end up with 2x, right, because negative exponents change location, and that's minus 1 because they're the same thing over the same thing. So this is a letter B. Divide using synthetic division. So synthetic division is going to tell us find the 0 of this. So that means I'm going to plug in a negative 1 into my divisor here, into that little box. 3 is the first coefficient. There is no cubic term, so put a 0 in there. 4 is my quadratic. There is no linear, so put a 0 in. And 3 is my constant term. Bring the 3 down. Multiply by negative 1. Add. Multiply. Add. Multiply. Add. Multiply. Add. That is my remainder. So that's the process, synthetic division. And remember, if I was doing synthetic substitution, my answer would just be 10. The fact that I'm doing synthetic division means my answer is 3x cubed minus 3x squared plus 7x minus 7 plus 10 divided by x plus 1. Okay, final answer. Looking at number 8 here, find the first term of an arithmetic sequence if the third term is 138. So t sub 3 is 138, and the 8th term, t sub 8, is 8. Well, it's arithmetic. It must have a common difference. So 138 minus 8 over 3 minus 8 gives me 130 over negative 5, which is a difference of negative 26. This problem should look familiar. We've seen this one before. Now we use our formula t sub n equals t sub 1 plus d times n minus 1. That is arithmetic. And I say, okay, which one do I want? 138 or 8? I like smaller numbers better. So 8 equals the first term plus the difference, which we found to be negative 26. If I chose 8 as my term value, I must choose 8 as my term number because this is t sub 8. So there we go. 8 equals t sub 1 plus negative 26 times 7. Negative 26 times 7, let's see, that's a negative 140, and that's 42. That's negative 182. I'm going to add the 182 over here and get 190 for t sub 1. So is that what I'm looking for? Find the first term. Check and check. So there's our answer, 190. Fancy 0 there, isn't that? So find all the zeros of p of x equals 2x to the 4th minus 9x cubed plus 2x squared plus 9x minus 4. So looking for the zeros there, we have the rational root theorem, which tells us factors of p over factors of q. So p is 4, q is 2. So the possible rational roots that we have from this problem, factors of p over q, plus and minus 1, plus and minus 2, plus and minus 4, all over plus and minus 1 and plus and minus 2. So if we actually take those fractions, I have plus and minus 1, plus and minus 2, plus and minus 4, and then all those over 2. So plus and minus 1/2, plus and minus 1 again, and plus and minus 2 again. So we have 4 pairs or 8 possibilities here. Let's take some easy ones. Synthetic division or direct substitution. If I plug in a 1, that's going to give me 2 minus 9 plus 2 plus 9 minus 4. 2 and 2 is 4 minus 4 is 0. 9 and negative 9 makes 0. So check. So 1 is a factor. So I'm going to do that by synthetic division because maybe this will come out to a factorable cubic that we can do by grouping or something along those lines. So 2 multiply, add, multiply, add, multiply, add, multiply, add. Not groupable there, unfortunately. But we can look for another 0 at this point. Notice we have the same p and q, which means our possible rational roots have not changed. 1 could, in fact, be a double root. In this case, it is not. I'm just trying to look ahead here if I can put in like a negative, if that'll do anything. Let's try 2. So we have 2, 4, negative 3. That's going to give us a negative 6. So 2 is not working. How about a negative 2? Negative 11. That's going to be too big. So 2 and negative 2 are out. Let's shoot for how about a half? I'm looking ahead here. Half looks like a winner. You'll see why here in a second. Question is it positive or negative a half? So 1/2. Bring the 2 down, multiply, and I get 1. I get negative 6. Half of that is negative 3, which gives me negative 8. Half of that is negative 4, which gives me 0. So there we go. So far we've come up with x minus 1, x minus a half, and here I'm looking at 2x squared minus 6x minus 8. A 2 comes out of all of that to give me x squared minus 3x minus 4, which then factors into x minus 4 and x plus 1. So negative 1. There we go. We have this 2 that's in front here also. So really, if I want to put this in true factored form, I'm going to distribute my 2 into here and get 2x minus 1. X minus 4. It turns out that negative 1 was a root. I just did not see that, I guess, when I was looking at it. So final answer, find all the zeros. X equals plus and minus 1, 4, and a half. There are solutions. Last problem for this video here. Find p of 1 plus root 3. So I'm going to do synthetic substitution. Coefficients 1, negative 1, 3, negative 2, and negative 1. And you might want to leave yourself a little bit of space on this one. So 1 plus root 3 is not a good start there because I just wanted the 1 to be brought down. So we'll bring the 1 down. Multiply 1 plus root 3. Well, here the 1 and negative 1 cancel out, so I'm left with root 3. Not too bad. Multiply, I get root 3 plus 1 this time. I want to change some colors here so I don't get too confused. Root 3 plus 1, so I add, I get root 3 plus 4. And now I'm going to start doing some scratch work here. 1 plus root 3 times root 3 plus 4. So that gives me 4 right there, plus that's going to be a 3 plus 4 root 3 and 1 root 3. So we get 7 plus 5 root 3. Add them up, I get 5 plus 5 root 3. And the last bit of scratch work here, 5 plus 5 root 3. And that's getting multiplied, remember, by 1 plus root 3. So I get 5 plus 5 root 3 from there, plus another 5 root 3 from here. And I end with a 5 root 3 times a root 3, which is 5 times 3. So 15. So I end up with 20 plus 10 root 3, which comes out to 19 plus 10 root 3. That is my final answer right there by synthetic substitution. It's a p-value. So that's part 2, second page. We will move on to the third page shortly.